What's up, everyone? Today we are continuing with factoring. Previously, we looked at factoring special cases. So we looked at those two special multiplication and factoring patterns called difference of squares and perfect square trinomials. If you didn't see that, go check out my previous video for help with those. Today, we're going to get started with factoring when our leading coefficient, also known as A, is 1. So we are working with slightly more and more complex types of factoring. And so this one is going to work for any trinomial that you've got going on when that leading coefficient is 1. So some vocab to get us started. You'll recall that a factor is a number that divides evenly into another number. So this is like if we think about 24, for example, it has the following factors. Let me write them as pairs because that's how we'll need to see them when we are factoring these trinomials in a second. But like 1, 24, those multiply together get you 24. 2 and 12, 3 and 8, 4 and 6, right? So this would be the product. Oh, it's not a great looking arrow. For the answer to the multiplication problem, and these guys here are the factors. Okie dokie. To factor an expression, so not like a number where we're writing it in terms of its factors, but to factor an expression is to rewrite the expression as a product, right? A multiplication problem of its factors. So to use the example we just gave, it would be like if I wrote 24 instead as 3 times 8. That would be a product of its factors. So we're going to do the same thing, just stepping up our game, because we're going to have algebraic expressions as our product and our factors. Factoring, you'll remember, is that inverse of the distributive property. So undoing, multiplying together. So our steps for factoring are going to be the same for all the different kinds of factoring that we follow. So we're always going to have the same couple of steps. That way, it's pretty streamlined process to follow. So we're always going to make sure that our equation is written in the standard form. So remember, standard form looks like ax squared plus bx plus c for a trinomial. Factor out a greatest common factor, or GCF, if necessary. So if there's multiplying into all of your terms, make sure you factor that out to begin with. And then we're going to notice the value of A. Again, that's that leading coefficient. So if A is equal to 1, so if A looks like 1, so our trinomial is something like this now, where we can write it as x squared plus bx plus c. We want to find values for p and q such that the following is true. We want to be able to rewrite our expression as x plus some number p times x plus some number q. Now, how do we find these numbers? So, for example, if we were to think about that expression FOIL, or to double distribute this back out, what would happen is we would have x times x. That gets us that x squared. Okay, so that's how I knew that was going to be there. Then our outside, outside and inside, we'll skip for a second. And let's talk about p times q. So p times q here that is what's going to get us C, this guy right here, our constant term in the trinomial. And then our inside and outside, I said we were going to hold on to that for a second. These, what happens here is we would end up with px and qx, and we would be able to combine those. So you would add p and q, and that gets you b, the coefficient on our linear term here in the middle. And so if we can figure out these two numbers, right, that they multiply to C and add to B, then we'll know how to factor this. So I always say factors of C that add to B. All right, so let's see this in action here. We're going to factor this completely. So we're going to go through those steps that were up here. So first, this is in the standard form, so we're good to go there. There's no GCF that can come out here, so we don't have to worry about that. Okay, and A is 1. So we know that we are looking for factors of 6 here that add to 5. So first I'm going to write out my factors of 6. So I always like to write out 1, the number, then we go 2 times 3 gets us 6, and then the next number I'm counting up right from 1 is 3, but 3 is already listed. Fun fact, once you get to the first factor pair that repeats, you've actually found all of them that exists. So then we can stop there. So these are our factor pair options, and we're looking for the ones that add to 5. So 1 plus 6 is 7. That one's not going to work. So that's how I know I'm going to select 2 and 3. So this is going to factor as 1 plus 2 times, or 1x, I meant plus 3. Now, I know what you're thinking. Well, that's all fine and dandy, but how do we know that that actually works? Something I think is super helpful, not only because you get to check your work and you get that like nice dopamine boost that you know what you're doing, but also because it helps us really establish the how of factoring, like why it works, is if we check our work by expanding, since it's the inverse operation. So to check our work, we're just going to rewrite this factored form here and go ahead and double distribute. So we'll have x times x, or x squared, x times 3, 2 times x, 2 times 3. So you can see here how 2 times 3 got us 6, and 3x and 2x are going to add to that 5x we started with, which is why we know our answer worked out. Great job. All right, now I know what you're thinking. Okay, I got the hang of this. Then I'm throwing a little wrench in here. Okay, this is just a little heads up, right? In the future, what's going to happen is we're going to be going about our lives in Algebra 1 or in Algebra 2 or in Pre-Calc, and we're going to have to factor something. And you're going to have to kind of figure out what's going on. And you won't always know ahead of time what method you're going to be using. So that's why I did sprinkle this little fun one in here, because it's helping us make sure we are thinking about these first couple of steps here before just jumping into that factoring pattern with P and Q. So is this in standard form? Yes, it's missing its constant term, but for what we've got, it is written right highest power on x to lowest. Now, let's check for greatest common factor. So I noticed that both of these coefficients are divisible by 3, and they each have at least x to the first power. So we are going to factor out a 3x, right? That is our GCF. And then what's left over is x plus 2. Now, x plus 2 is just a linear binomial. There isn't anything that can be factored in here, so we can't work any further. So that is it. All right, next one. All right, back to our regular scheduled programming here. So this is in standard form. There's no GCF and A is 1. So we are going to start thinking about 10 and factors of 10 that add to 7. So factors of 10 are 1 and 10, 2 and 5. 1 and 10 gets us 11, but 2 and 5 gets us 7. So I'm going to rewrite this as x plus 2 x plus 7. And one last time, we're going to check our work. I totally encourage my students to keep this up as long as I feel like it's helping them to double check, right, to feel confident in their answer, but also to recognize the pattern here that we are trying to undo in factoring to really get that why of the factoring and not just memorizing steps for steps' sake. All right, so we will get out. Oh, do you guys see my mistake? This is why we check our work, guys. I put 7, but that's going to multiply out to 14, which isn't what we were supposed to do. And 5 was written right there. Oh my goodness. See, this is why we check our work right there. Shameless plug. All right. What had happened was I changed on accident. I had been writing in my P's and Q's with the green color, and I wrote them in with the pink, and I was thinking about how I had made that mistake. It's not really a mistake, and that's what messed me up further. Oh geez. All right, let's try this here. This is looking a lot better. So we've got 5x, 2x, and 10, and now we've got that x squared plus 7x plus 10. Did you catch my mistake while you were working along? Were you thinking, oh, Kaylin, no? That's okay. All right, next. All right, we've got standard form here. Ooh, but we've got GCF because all of my coefficients are even. So I'm going to factor out a 2. So we've got 2 times x squared minus 3x minus 40. All right, so this is important that we have to do first because now we are looking at factors of negative 40. All right, so here's what I do. I'm going to tell you a little secret. I'm just going to ignore the negative for a second. Come on, scribble erase. And we'll just think about 40. Okay. So, this, by the way, that's our GCF. Factors of 40. 1, 40, 2, and 20. The reason I do this, by the way, some of you might be like, oh, well, I can just think of the factor pairs all in my head. But I know for a lot of students, even if they do feel really comfortable with their times tables, having a way to organize your thoughts is super, super handy. When you're just trying to think of as many factor pairs for a number as you can and then see if they add up to the correct number that you need or not, it can be hard to think, have I thought about all of my factor pairs? Did I skip one? Did I try one already? And so this way I've found really helps students stay organized and keep track of their thinking. And that way we're not thinking, oh, this just isn't factorable, when really there's just one more factor pair that we hadn't thought of. So 1, 2, 3 does not go into 40. I don't know why I wrote that down. 4 goes into 40 10 times. 5 goes into 40 8 times. All right, now here's my trick. Remember, we know because this multiplies to a negative number that exactly one factor is negative, okay? because that's the only way to get a negative product, okay? So negative means one factor is negative, exactly. And then because here the sign is telling us that the sum is negative, when we added them together, we ended up with a negative number. That means it's the larger factor that's negative, since it kind of won out in the fight with the positive factor. So now what I do is I just go ahead and negate all of the larger factors, which is another reason why it's super helpful to be able to write our work out this way. Okay, so here are my factor pairs, and I want to add these numbers together, and I want to see what gets me that negative 3. So 1 minus 40, nope. 2 minus 20, nope. 4 minus 10, nope. Last but not least, 5 minus 8 gets me that negative 3. So we still have our 2 out front. Don't lose your 2 here. And we're going to have x plus 5. And now because 8 is negative, we'll just write it in as x minus 8, like so. So again, if you wanted to check your work, you would I personally would double distribute first and then distribute my 2 into all 3 terms of the trinomial. But you could also distribute it first to one binomial, not both of them, but just one of the binomials. So like if I distributed it to x plus 5, and then I took that 2x plus 10 and double distributed with x minus 8. I could check my work that way. All right, you guys are doing such a great job here. We're gonna just do, look at this, a couple more of these, and then we'll come back and check our work. So go ahead and work these problems out on your own. Pause the video, and then we'll come back and go over them together. Welcome back. All right, so here we've got x squared minus 6x plus 9. I know that we are looking for factors of 9 that add to negative 6. So here, both of our factors are actually going to be negative. So we're going to want negative 1, negative 9, negative 3, negative 3. Reason being is because they multiply to a positive number, but they're adding to negative 6 here. And the only way to have that happen is if both factors are negative. All right, so let's factor. I discovered that negative 3 and negative 3 adds to negative 6. So when I factor this, I'm going to end up with x minus 3 times x minus 3. Oh, but I can write that even more simplified like this, x minus 3 quantity squared. And you'll recall from our previous lesson that that was a PST, or a perfect square trinomial. So we could have actually saved ourselves some time and just jumped straight. If we realized this is a perfect square trinomial, we could have just jumped straight to this factor form. If we recognized that our trinomial was of that form, a squared plus 2ab, or in this case, minus 2ab plus b squared. So, keeping that in your hip pocket, did you notice that this next one was also a perfect square trinomial? So, because this one was also a perfect square trinomial, we could go ahead and factor it as x plus 2 quantity squared. Now, you could do it the longer way, of course, but remember, we're not just looking for like the correct answer. That's fine and dandy, but we want to get there as efficiently as possible. All right, it just wants this to be a trapezoid, so it's going to be a trapezoid. Next, we have 3x squared minus 3x minus 60, and this guy here has a GCF that needs factored out. So we're going to factor out a 3. So now we're going to have x squared minus x minus 20. So we looked at factors of negative 20 that added to negative 1, and we went with 4 and negative 5. So we've got 3 times x plus 4, x minus 5, like so. Ooh, this next one, I wondered if you caught this. This was not written in standard form. First, we needed to rewrite it as x squared minus 5x plus 6 and put it in standard form. Now we're looking for factors of 6 that add to negative 5. And so this time it was negative 2 and negative 3. And so this factors as x minus 2, x minus 3, like so. All right, last but not least here, the only difference you'll notice between E and I here, you might think, oh, she gives the same problem in a row, but not quite. Remember, this is again going to be a perfect square trinomial, but I want you to notice this sign here makes all the difference. So what's going on here is this is actually going to factor as x plus 3 quantity squared. So we'll have to make sure those signs are really important for what we're doing here. So if we had mistakenly put a negative and then tried to expand and factor it back out, we wouldn't get the trinomial that we started with. So you're going to want to be careful there. All right, last but not least, we looked for factors of 18. So we had 1 and 18, we had 2 and 9, and we had 3 and 6. Everybody had to be negative so that we could multiply to a positive 18 to add to negative 9 here. We went with 3 and negative 6. So this looks like x minus 3, x minus 6. I know that factoring gets a really bad rap, and I actually struggled with it quite a fair amount when I was first learning in Algebra 1. But the good news is that is a skill. It might feel like bad news, but the good news is that it is a skill that is sticking around. So from Algebra 1 to maybe some geometry to Algebra 2 to pre-calc, you are going to be factoring. And so that is not bad news, right? That this isn't going away, but that's good news because it means lots and lots of practice coming your way and opportunities to improve. Have a good day, everybody.